Hello everybody, I hope you're doing well today. I would like to continue on my discussion on salt questions. And this question is taken from MRSM 2004. Question 4 is a structured question. Okay, if you look at the question, you will see that Mg reacts with HCl. So let's write the equation first. Mg reacts with HCl will give you, alright, so Mg is more electropositive than hydrogen. Therefore, Mg will displace hydrogen from HCl. So it will combine with chloride ion. Mg is Mg2 plus, chloride ion is Cl negative. So therefore, we have two Cl negatives. And the H is displaced as hydrogen gas. Okay, so what is solution E? Solution E is MgCl2. And what is gas R? Gas R is hydrogen gas. Okay, then we can see in phase 2, MgCl2 reacts with PbNO3. So let's write the equation again. MgCl2 reacts with PbNO3. So just change partners. Mg2 plus Cl negative, Pb2 plus NO3 negative. So it will become MgNO3. So there you have it, magnesium nitrate. And the other one will be lead. Okay, I'll write it here. Lead 2 chloride. Okay, so substance G is lead 2 chloride. Okay, let's look at the questions now. So the first thing you'd always do is look at the diagram given, write all the equations, and then go to the questions. Name solution E and substance G. So solution E is magnesium chloride. Now please remember to name. Name means you have to write the full name. Magnesium chloride. And gas, substance G. Okay, substance G. What is substance G? Name. Lead 2 chloride. Okay, back to questions again. Explain how you can identify and confirm the presence of gas R. Okay, so if you look at your textbook, right, you will see this page on the experiments to test the gas. Okay, so we know that this gas is hydrogen gas. So how do we test the hydrogen gas? Okay, so we place a lighted wooden splinter near the mouth of the test tube. Okay, and then you need to also mention what is your observation. So your observation would be a pop sound is heard, confirming that it is hydrogen gas. So normally these kind of questions will give you 2 marks. Right, first mark will be for the what you do, right, and the second mark will be for the observation. Okay, so first mark is place a lighted wooden splinter near the mouth of the test tube. And the second mark is a pop sound is heard, confirming that it is hydrogen gas. Okay, let's look at question C now. In phase 1, hydrochloric acids reacted with magnesium powder. Let's write the chemical equation. So hydrochloric acid is reacted with magnesium powder. Right, as I said earlier, magnesium is more electropositive than hydrogen in the electrochemical series. Therefore, magnesium will displace, okay, the H. Displace means kick the H out basically, just kick it out. Right, so H comes out as hydrogen gas. Now, all these gases like hydrogen gas and oxygen gas or nitrogen gas, right? what else? Oh, and all your halogens. Okay, fluorine, chlorine, bromine. These are all halogens. They must all exist as a diatomic compound. Okay, they always exist as a molecule. Right? It cannot be one H alone. It has to be two H together. So that's why it's H2. Okay. Of course, you got to balance the equation. There are two Cl's over here. Alright, so there should be 2 HCl. So 2H and okay, there are 2H. Right, so the left side of the arrow and the right side of the arrow must be balanced. Okay, so that's your equation. Right, let's look at the next question. So maximum volume of gas R that can be produced at room condition. Okay, let me just rewrite the equation here so that it's easy to refer to. Okay, so we have HCl plus Mg. Okay, MgCl2 plus H2, and we want to balance the equation by putting a 2 in front. Okay, so from the question earlier, we're given hydrochloric acid that we use 20 cm cube, alright, and 1 mole per dm cube. Okay, so let's write it down. The M is 1 mole per dm cube. This is molarity, and the volume that we are using is 20 cm cube. Okay, so 1 mole per dm cube and 20 cm cube of HCl. So we just write it down here. Okay, magnesium not mentioned. Molar volume is given. Okay, so the first thing you do always in this kind of calculation question, okay, there are 3 steps. The first thing you always do is to find number of moles. Okay, 3 steps. First one, number of moles from the information that you have from the question. So there are a few ways to find number of moles. You can use the triangle formula, or you can use, in this case, you can use MV over 1000. So number of mole of HCl. Right, so M molarity, you have 1. Right, V is 20. Alright, and because this is dm cube and cm cube, we have to change the cm cube to dm cube. That's why we have to divide by 1000. Okay, so let's calculate that. So 20 divided by 1000, that's 0.02 mole. Okay, now what's the second step? The second step is to look at the ratio in the equation. So this one we have the information for number of moles, and we want to calculate volume of gas R. That means to say we want to calculate the volume of hydrogen gas. So we need the number of moles for hydrogen gas. Okay, so we want to compare the number of moles in the equation. Okay, so from the equation, 2 mole of HCl will produce 1 mole of H2. So therefore, from the experiment, we can see that we use 0.02 mole of HCl. So therefore, the number of mole for hydrogen gas that will be produced will be half of that, because 2 get 1 from the equation. So 0.02, you get 0.01 mole of hydrogen gas. Okay, so now that you know the number of mole for your hydrogen gas, okay, we can use the triangle to look for volume. So volume is equal to number of mole, alright, times molar volume. Okay, so what is volume of hydrogen gas? It is equal to number of mole of hydrogen gas, which is 0.01, times molar volume. Molar volume is given here. Okay, molar volume of gas at room condition, that's 24. Okay, so we want to times that. 0.01 times 24 is 0.01 SPM04-04. So this is, because this is given in dm cube, so your answer would be in dm cube. Alright, so that's the answer. Okay, let's move on now. Name the type of reaction that took place in phase 2. Okay, let's go back to the diagram. Phase 2. Okay, what type of reaction is this? MgCl2 plus PbNO32. Okay, phase 2. Okay, so we have magnesium chloride, right? So is this magnesium chloride a soluble solution or not? Is it a solution or not? Is it soluble? Okay, so we refer back to the page in your textbook. Yeah, this one. Okay, so all chlorides are soluble except for PAH. P-A-H. Okay, check PAH. So chloride, back to the diagram again. So this is soluble. Okay, all chlorides are soluble except for PAH. P-A-H. So this is soluble. Okay, and then we know that all nitrates are soluble. Okay, all nitrates are soluble. So you can see here, all nitrates are soluble. Okay, so this is also a solution. Now, when these two react together, okay, it produces magnesium nitrate. Okay, all nitrates are soluble. So this is a solution also. And it also produces lead-2 chloride. Okay, so we want to see, is this lead-2 chloride soluble or insoluble? Okay, so we look at, we look at this again. All chlorides are soluble except for PAH. P-A-H. There we go. Pb, right, that's lead-2 chloride. So lead-2 chloride is insoluble. Now, if lead-2 chloride is insoluble, this is insoluble. Okay, so what reaction is this? A solution plus a solution that mixes together gives you a solution and a precipitate. This is insoluble, so this is also called a precipitate. Alright, so the answer is double decomposition. Okay, let's move on. How do you separate substance G from the products mixture? So now you have two products, right? One is a solution, one is a precipitate. How do you separate? So all you have to do is filter. Okay, so you filter, and also once you filter, then the residue, okay, is your substance G, the precipitate. Okay, so you filter the mixture. Okay, the residue is your substance G, and if you want to get dry substance G, you use two filter papers to dry it. Okay, so basically it's like this lah. You have a beaker with precipitate. This precipitate is substance G and the solution. Okay, you want to separate these two. So you filter the mixture. Okay, the solution will go down here, right? And this will be substance G is the residue. Okay, and we dry using filter paper. Okay, so that's all for this question. Thank you for watching.